Hello everyone, in this video we're going to talk about the theory behind derivatives. We're going to define what a derivative is, then we're going to talk about what a slope is, and then we're going to tell you how to find the slope of a function using the derivative function. So what is a derivative? The derivative of f of x with respect to x is the function f prime of x and is defined in the following way. We're going to explain to you what this means exactly, but for now, what's important to know is that the derivative of a function represents its slope at any given point. To understand the use of a derivative, it's important to understand what a slope is. As you can see in these three different pictures, we have straight lines, and what's different between them is the inclination that the little man has to walk up. As you can see in this part, the inclination of the line is not represented by the change of x, as this is the same in every single line, rather by the change of y. For example, in the first picture, your change of y is equal to 0, so you have a simple horizontal line, while this is not the case for the other two pictures. Seeing as x and y cannot be separated from each other, your value of slope is going to equal to the change of y over the change of x, which can also be represented in this way. Another way to describe the slope is the rate at which the line is changing, which is equal to the gradient. So these are just two terms for the same thing. To finalize, here is an example of the calculated values of slope for each of the figures. So as we saw just now, calculating the slope of a straight line is fairly easy, as you only need to do the change in y over the change in x, and this is going to give you the same value wherever in the line you calculated. But if you have a curve, and you do the change in y over the change in x, that's going to give you a different value over here than it would give you over here, because the gradient is not constant. So what we can do is pretend that there is a line between these points and try and get the average between these. So this is just a representation of what I drew on the board. As you can see, we have these 2 points and the average slope between them is represented by g. However, this is very inaccurate, as soon as we move b, the slope of g is going to change drastically. So what we want to do to make this as accurate as we can is to move the points a and b as close together as possible so that the difference between them is going to be almost 0 and they will be overlapping. What this results into is basically having this tangent line that is going to accompany your curve at any point where you choose. And the slope of this tangent is going to equal to the slope of the curve at that specific point. So as we saw for a straight line, to calculate the slope, you do the change in y over the change in x. However, for the curve, we just saw that we want to make this change as little as possible. We want to approach these points as much as we can. Therefore, we're going to represent it like this instead, dy over dx. And dy over dx is going to be the same as if you were writing f prime of x. So this is going to be how you show your derivative. Okay, so now we're actually going to show you how to calculate this. And for the sake of convenience, I'm going to keep these points this far apart, but you know that the principle is to try and put them as close together as possible, so just don't forget. So let's say that the distance between this point is going to be h. And that's going to mean that this point is going to be, for example, your value of x, and then this point over here is going to be your x plus h. And by logic, that's just going to mean that this point over here is going to be your value of f of x. And this value over here, corresponding to this point here, is going to be your f of x plus h. This is how you represent it mathematically. So you have your dy over dx, and then you do this. This part is just meant to represent that this space between these values needs to be as small as possible, so it goes towards 0, the limit. And then this space here, you're just going to include the difference between these two values of y, so your dy, and in the denominator, the difference between your values of x, which I don't have space there, but it's going to be your dx. So This can be simplified in this way. If you just cut these x's out. And you would have this. So this was the theory behind derivatives. If you use these rules, you're going to see the different patterns are going to emerge to get the derivatives for different kinds of functions, and these will all be explained in later videos.